right? So if you look at the schedule, I updated probably last weekend. You can see this Friday will be the one homework, which is homework 6. It's the PID control the photocell project is due on Friday, and we got homework 7, which is the smart robot car. Sounds like it can be complicated, but actually it's only a 1 week, I believe. That a little bit more than 1 week assignment, right? Because it's not that difficult, right? It's just most of the code already provided to the tutorial, and you just modify that a little bit, do all the demonstrations, and that's it for homework 7. And homework 8 is soldering and testing of the oximeter PCB, which is due the week after the spring break, April the 3rd, Monday. Do we have enough time to work on these? So this week you haven't done this yet, right? So this will be done by Friday. And then Friday you may have some time or may not to work on the car project. Okay, I probably will delay this one a little bit to Wednesday of this week. Okay, so you got some time to solder and test your oximeters PCB and make a product out of it. All right, that sounds reasonable. Okay. And I used to have more projects over here of using not just the Arduino IDE, but the ST32 microcontroller, which is also very popular microcontroller in the industry. I removed them because we got a lot of cancellation of the classes at the very beginning of the semester. I have to remove it. And these two projects are really practical. Both of them are from my industry contracts. And the first one is the Pulsar Springs 24 temperature monitor network, and the second one is the horse shoes project. So we designed a very small PCB and put it into the horse shoes to protect the laminates of the horses, the horse legs. And both of them are super practical. You are just saying, hey, we only have 2 projects left for the semester, but probably you'll learn the most from these 2 projects. Okay. And now let's get into here. I just told you this is a very simple project, even though it's like a product, because we ordered all these kits, so you can directly use it. You don't even need to assemble it. It's already assembled by the past students. So first, this little car has a ultrasonic sensor. One is the transmitter, one is the receiver. If you look at the sequence here, that's a timing diagram. It's not exactly the timing diagram, but it's just showing you the concept of what's happening for that ultrasonic sensor. So the transmitter is going to send just an electrical signal. So the trigger input pin is a physical pin on that module. So it sends a pulse. That's a digital pin. That's a digital voltage. Okay, and that digital voltage is from Arduino, and Arduino sends that voltage or a pulse to the ultrasonic sensors module, which is a trigger pin, send a pulse to it. And this module is going to convert it into a ultrasonic burst, just a couple pulses. And this is not voltage anymore. Keep in mind. This is a sound signal. It's being triggered. So that's why I'm saying this is just a concept. It's not really a timing diagram. It's not showing the time. It's just showing a concept. So you send a signal pulse to the module from the Arduino, and then the ultrasonic module will directly send all these sound signals like this physically to the outside world. It's going to be sent from it's a sound signal, sonic burst, okay, from the sensor. And if there's something in front of the sensor or the transmitter, like obstacle in the front of it, that's going to reflect, bounce it back. go. So that sound signal will be bounced back, and then the receiver, I don't know which one is the transmitter, which one is the receiver, but one of them is the receiver, one of them is transmitter, okay? And the receiver will receive that reflected sonic signal, okay, and then trigger a voltage pulse. And this pulse will be, because you have the physical connection, it's a wire connection from the sensor to the Arduino, so this pulse will be sensed by the Arduino, okay? And then the Arduino will be able to find out the time from here to here, which is the time of the the sonic signal takes to travel from the sensor to the obstacle and then back, right? So this is actually a round trip. And since you know the speed of the sound is like 340, I forgot, like 340 meters per second. And you know the time, so you can calculate the distance between the sensor or the sonic sensor and the obstacle. So that's something you can calculate in the microcontroller, just a very simple division calculation, okay? And so you can use this one as a obstacle avoider, because whenever you actually program an if statement, whenever the distance is lower than something, you stop the motor, right? So this can be used as an obstacle detector or avoider for the car. And at the bottom of the car also, it has, I think, 3 or 4, I forgot, pairs of IR sensors. So the IR sensor is just the IR receiver and transmitter pair. It's very similar to the oximeter's IR pair, okay? It's transmitter and receiver pair. And so this car will receive the signal of the reflection from the floor. It can be a very light color, like white color paper or board, or a dark tape. So the dark tape, the black tape you can see on the tile in the lab right now. So the tape is very dark color, and it's going to absorb. It's going to absorb the IR light. It's not getting reflected. But if you have a very light color surface, it's going to reflect most of the IR light, and so the receiver will receive it. So you can tell the difference of a black tape or the light color surface of the floor. Okay, so in that case, you can adjust the position or the speed of the motor in order to keep the car on track. I don't know if it makes sense. Have you worked on any of the car project like this? A little IR sensor at track line somewhere. So if it's out of track, right? If it's out of track, then the sensor here will sense the light color on the floor, and then stop will stop the motor here, right? For example, it's out of track this way, we'll stop the motor here, keep running, just moving it back to track. That's how that works. Very simple feedback system. There's not even the PID controller. Some of the car projects they have PID controller in there, but we don't even need it. It's working super well. So it has 3 pairs of IR sensors. And let's see. So let's look at the final goal. What's the goal you want to achieve eventually for this project? First, you need to use a remote, okay? A remote controller you used in the last project to control it. And so you need to set up, so you are not allowed to reprogram it and then to implement the next task. It's all embedded into the same controller. So just use your remote controller to switch in between all these different modes. For example, you press number 1, it's going to trigger the line tracker mode. It's going to track a line. If you press number 4, it's going to start the obstacle avoider mode. It's going to avoid the obstacles. And maybe mode number 2, it's go places, right? It's a driving mode. You can use different keys to drive the car, going forward, backward, left, and right. but you are not allowed to reprogram it to get the car into different modes. It's all already programmed in the car, and then you just use the remote switching between all these different modes. Okay. So at the very beginning, I used the driving mode, right? That's why I drive the car to the top of the line, and then I trigger the line tracker mode. It's going to start tracking the line. You can see the tail's color doesn't have to be super light. As long as it's not dark, I think it's going to work. And then I trigger the obstacle avoider mode. It's going to find a way out from the maze. So what's happening is whenever the car is very close to an object in the front, the ultrasonic sensor will sense it's too close, right? And then it's going to stop the car first, and then it has a servo motor with the ultrasonic sensor. It's going to turn left and right to see like which direction has more space, and then it's going to turn to that direction. It sounds like pretty complicated, but actually most of the code has been provided to you guys. You are not actually inventing the algorithm in there. It's just reusing it and modifying it. It's more about the learning process instead of creating. Another thing is you see this car successfully find a way out from the little maze, right? But when you are doing this, it might be not that repeatable. It also happened to me. I just, if I put a car in the maze, probably 2 out of 5 times, it's going to stay in the maze for a long time until it's find a way out. This is just a lucky time, right? It's just getting out really quickly because it only has one sensor on the car. So it's turning left and right. Sometimes if the car end up in the special corner, it's very difficult to find a way out. It's not that smart. Just one sensor, one dimension. It's not a video, processing system. It's not. There's no AI involved. So expect that. Okay. Doesn't have to be perfect. As long as like you try it for 5 times, like 1 of the 5 times, it's successful. It's okay. Just record it and post it. Okay. I can see that there's an official PDF instruction for the maze solver obstacle avoidance car, right? This is from the same company that manufacture the robot, and you don't want to directly use their code. You have to do whatever I just demonstrated to you guys, because if you directly upload this code to a car, it's going to work in a different way, but it's going to work out. So it's just a copy and paste the process. Don't do that. So what I'm going to ask you guys to do is it must, whenever it reaches a corner, it must turn left, turn right, like whatever I just showed you guys here. Right, so now I have this one programmed. And then find the way out. Okay. Take a second look at it. Where's the maze? Let's go. No, I haven't. This one. Take a second look at it. Okay. See, when it stops, it turns left first. Okay. And then turn right. Okay. So I just left, right, and then it's done. Then move the servo motor to the middle direction. It's 90 degree, I think, or 0 degree. I think 0 degree for the middle, and then turn left is 90 degree, and then turn right for 90 degrees as well. If you use the code from the PDF instruction, it turns the motor in a different way. I can easily tell that. I think what that does is turning left really slowly, and then move it to the middle, and then turn right very slowly and move to the middle. And I think it does that for twice before it makes the decision. And the performance was not improved by doing that. It takes a lot of time and very slow. Looks like not as smart as the one we have here. So I think it's good enough. Just turn left and turn right, and then move to the middle, and then make the decision. It's good enough. Okay, so please program the car in that way. And another difference between the one we have, like the demonstration just shows you in the demonstration, and the one that provided by the manufacturer is, like I said, we have all the modes already programmed in the microcontroller, and then you use the remote controller to switch in between all the different modes. Okay? But the code provided by the manufacturer you can find online. It's available. If you search for Alago smart car, robot car, you probably can find a zip file on their website and download it. It has all the code in there provided. It has all the script for each task or each mode, but I don't think they have an integrated mode or script that have all the modes in there and using a remote controller to switch in between all the different modes. So that's something you have to integrate or modify. Another thing is, I used to have a lot of these remote controllers, but I couldn't find most of them right now. But I think you guys have your remote controller in your box. If that works fine, you can keep using that one, and you just assign different keys as the arrow keys. If you don't have the arrow keys on the remote, you can redefine other ones as arrow keys to drive the car. Okay. Anything else I want to talk about? Okay, so it's not just the one project that has all the taking all the baby steps. First, you just program the ultrasonic sensor to get like 30 points or something, right? It's taking the baby steps until the very last step. All right, I think that's everything I want to talk about. Any questions you may have for this? And batteries, I already put the batteries in the charger over there, charging up. And I have more of the 18, the number of it, but these chargeable batteries have a lot of them. The chargers you can find out here. You can either grab one with you, or you can just keep them here, and whenever you are done, just switch or fully charged one and put the that ones into the charger. And so you can see these boxes, this one, this one, this one. They're all the chargers. I have a lot of them. Batteries are in this box. I have 2 cells here, but I have like 100 in my office. Right? Some of the batteries may be dead. So the way to test it is, because every LiPo battery cell is a 3.75 volts in theory. Because usually if they are fully charged, they should be like 4.0, 4.1 volts. So before you use it, definitely use the multimeter to probe the 2 terminals, see if it's 4.0 or 4.1 volts. If it is, then it's ready to use. If it's not, like only 2.something volts, which means the battery is dead. You have to give it to me. I will, just throw it into the box to recycle it or something. Right, so these batteries are not just a single battery. They have an IC chip inside, controlling the charges, the current of the charging. It looks like it's just a battery, right? It's not like the AAA, AA pad batteries. They actually have a integrated circuit in there. Pretty cheap, anyway. Any other questions you may have? Yeah. Yeah, I will change the deadline for the oximeter to Wednesday on April the 5th. Okay, give you guys more time. Any other issues with the PID controller or any other, questions for the other projects? Do you need any help from me? Doing well? Okay.